So hello everyone, welcome you all for today's Kubernetes webinar hosted by MindMajix. So welcome you all and thank you very much for joining in. So let's proceed further. So before we move ahead, let me give you an overview about MindMajix, what we are into and what we do. So just to give you some background about MindMajix. So MindMajix is basically a leading global online training platform, and we are holding almost, it's been 8 years now, and we are almost into all type of IT courses which we host, and we use various platforms for IT training. It's basically online, which we prefer most, where people can connect across the places and all the professionals. We are working professionals. So what we do, we do online training for working professionals so that they can connect from wherever they are, right? Whether you are in US, India, UK, Asia Pacific, so that we do extensively. We also provide various classroom-based trainings also. Offering wise, if you look at our offering, we already do 500 plus IT courses worldwide, and we do on various domains, particularly in project management, big data, business intelligence, analytics, cloud compute, data science, DevOps, databases, programming and frameworks, RPA, and many more courses. Like the list is huge. And our instructors are also industry certified experts, and which we have almost 10 plus years of experience in specialization into particular domain. So all our instructors are highly qualified instructors. We have already trained more than 110K students around the globe, and they are excelling very much into their career. So we train people, we bring into certain level and to the people, so that tomorrow if they are looking for a job, or they are looking for a skill change, or they are looking want to upgrade their skills, so they come to MindMajix, and MindMajix is the platform where we train people and with a lot of hands-on experience. We also update our course content every quarter. So we review our course content, and along with the market, whatever the new technology is coming in, we also do upgrade course content, because all our training professionals, they keep on eye and they have all expertise into end. So we also upgrade our training modules as well. And we deliver best in class training, right? So we do all at corporate levels, student level, and various worldwide. So we are associated with various corporates across the globe, and we train people from all over the world, right? So that is all about MindMajix. Just to give you the fair background about MindMajix, so that you can have a feel of MindMajix, right? Officially, you can also visit our website, which is mentioned below link, and we can also reach to we have offices in India and US also. You can reach from US also, the numbers are mentioned here. You can reach out to us in India also. So we have a presence in US as well as in India. Let's talk about Kubernetes, right? So I would be giving you a lot of insights on Kubernetes, and I'll take you through all the things what we do under Kubernetes, how we train people, what all things we take care under while training the people, right? What would be our method of training the people, and how we prepare for certification, because Kubernetes is making a huge buzz in the market, and it has already entered into a mainstream, right? Because everybody is using Kubernetes extensively for their routine jobs. Whenever we have application, we want to manage the applications right from right when we create it, when we start it, when we stop it, and so on, right? So all my complete deployment can be managed by Kubernetes. So I will walk you through a lot of things on Kubernetes in this session. So under MindMajix, what we do about Kubernetes, so we provide in-depth knowledge on Kubernetes. So we don't need any prerequisites from anyone. People can come from any background, whether it's a systems engineer, senior system engineer, network support people, right, so developers, or a testing background people, right, or even a project management people, or even the architect people, right? So what we do, we provide extensive training on Kubernetes, right? Kubernetes is basically a API, application programming interface application. It basically what it does it, we have a micro service based architecture, and microservice based architecture, when we host application into a modern way of developing a software application or a software solution, right, so that we can deliver the product faster in the market. So that is the only way. So what we do here is, we don't use monolithic approach, we use we use a microservice based architecture, and what we do, we slice down a monolithic application into feature by feature, right? And what we do, we take care of complete deployment by giving a hands-on experience. So when we train people, what we do, we create our own production environment, and we right from the fundamental, right from the ground level, what we do, we create the entire cluster, we create application, we host the application into containers, then we start deploying it. So we give a complete hands-on session here, and we will train people on completely on a hands-on, practically on hands-on things, so that people can be able to tomorrow, if they go get a job, or if they go to they upgrade to a new role into DevOps, so what they can do, they can independently, they should be able to manage the entire Kubernetes cluster, right? So till that level we will bring you by giving you a lot of hands-on sessions. We take production use cases with real-time examples, we do a lot of assignments, right? All that we do under Kubernetes. And another thing is, when we train people, right, so our entire course is crafted into a certified modules, right? So whatever the certified official curriculum of certification, we have same thing we have taken up, and we have crafted our entire course into a certification thing. So while training the people, we also take care of their certification upgrade, right? We train people, and we provide a lot of tips, we provide a lot of tricks, tips, and a lot of hands-on experience by taking real-time examples, and that way we are preparing people for go for certification, because certification gives again a value add to your current role, current profile, and current expertise, right? So we do a lot of things, right? So Kubernetes, we do extensively design a program for a professionals, where we train people right from the fundamentals, basics, and eventually we move towards an advancement, right? We give advanced training, so that tomorrow you get onto the job, you should be independently able to manage the entire thing in Kubernetes, right from development, deployment, right? And all that thing, whatever it requires to be under Kubernetes, right? So taking care of scaling, rolling update, right, rollback, everything, logging, resource quota, right, services, everything we do under Kubernetes. And we also prepare for Kubernetes certification. So here we take care of CKA. Normally we have two types of certification under Kubernetes. CKA is basically Certified Kubernetes Enterprise, and another is CKAD, which is Certified Kubernetes Application Developer. So all that we do, and as I said, we have crafted our course in such a way that while training the people, we will also prepare for certification, because all the course modules are depend on our certification, right? So that we do. And for extensive course curriculum, you can go to the link and you can get all the details what we do under Kubernetes training. So you will get all the details here once you visit to the link, right? So anyhow, I would be talking in details again here, right? So this is just a gist to give you before we deep dive into the Kubernetes thing, right? So I'll walk you through everything what we do under Kubernetes, how we do, right? What is our style, what is our methodology, what we are going to follow, how we will be training the people, and eventually, right, when at the end of the day, you should be able to independently, you should be able to do what is expected from Kubernetes, right? So all that we will be doing here. So let's move forward with this thing. Now these are the topics for today's webinar, right? So these are the high level bullet points. There are underneath, there are many things which we would be covering, but these are basically a high level thing. So this would be the agenda of today's webinar. So we'll start right from understand the container orchestration, then we will move ahead with what is Kubernetes, what are the advantages of Kubernetes. Then we will also explore, right, just to give you a feel of it, right, what is the job market of Kubernetes, right? So we will just visit and see, right, what is the pay scale, what is the salary expectation, what are the opportunities outside in the current market, whether it's the US, India, right, UK, Asia Pacific, across. Kubernetes and DevOps are the hot things, right? And a lot of job openings are there across the globe. So we will even have a feel of it, right? So I'll walk you through what are the salary expectation, what are the job market, and what are the career opportunities. Then we will also understand Kubernetes architecture. I'll also talk something about Kubernetes installation process, because that is where everybody is looking for. We will also see how we can create Kubernetes cluster, and how we can eventually we can quickly set up even development environment also, right? So we will see all the various types of services which are available. and I will also explain about secrets and some deployment strategy, and eventually at the end we will have question and answer sessions, right? Make sense? So let's move forward and start our thing in Kubernetes. So container orchestration. So we know that in this modern world we host all application into container based environment, right? So basically container orchestration can be used in any environment where you use containers, right? So when we use containers, my application can be hosted inside the containers, and eventually containers are everywhere, right? So we need some tool who can be able to help and who can manage my container. So container orchestration is all about that. And in container orchestration, right, is all about managing the life cycle of container, especially in large and dynamic and complex environment. Kubernetes helps us in a way forward. It also helps to automate the deployment and manage it across the life cycle. It also helps, like, while when the traffic is more, we can use Kubernetes as a scaling thing. It will scale up, and when the traffic is less, it will scale down. So all that we can use, and Kubernetes will also help me to even optimize the cost, right? So that as and when the resources are required, it will utilize the resource, and as and when the resources are not required, it will release the resources. Because in this modern world, what we have is we have a cloud compute model, and what cloud compute model says is pay as you go, right? So we have a scaling feature under Kubernetes, which will help me. When the traffic is more, we will scale up, and when the traffic is less, we will scale down, right? So all that we do under container orchestration, right? Containers gives basically all our microservice based application. We can ideally host all that application under Kubernetes as a deployment unit, and we can even self-contained execution environment can also be created under Kubernetes, right? So basically it's a unit of deployment, and we can host application into a containers, and then containers complete lifecycle can be managed by Kubernetes. So that is what about container orchestration. We can also manage the lifecycle of containers with orchestration with the support of DevOps teams, right? DevOps teams who will day in, day out, who will work and who will support the lifecycle of container and manage the orchestration things under Kubernetes, and which will also help to further integrate with CI/CD pipeline, right? So we have a CI/CD workflow where right from my development, right from my testing team, right from my support team, till my product is delivered to the customer, right? All these teams can work in a parallel mode, right? What happens in traditional way? In traditional model, what happens is until and unless my development is ready, right, my testing team cannot start it, right? They have to wait till the development is ready, right? So my testing team is ideally it's idle, right? They don't have any work, right? So it basically what happens is they work in a sequential way, right? Once my development is done, it will be assigned to testing, and then testing work will start, right? So they then my further deployment will start, right? Then where my UAT and all that will start, right? So we have various things, but that would be a sequential thing. But under DevOps, what we do, we have a parallel thing, right? Right from my development, right, as and when my development is started, right? So what we have a CI/CD pipeline workflows. So where what we do, we integrate each and everything as and when my developers, when they do check-in, right? So with a new check-in in my version control repository, it will trigger a build, and the build will happen, right? So build will be done. Once the build is done, it will be, or there will be a job which will pick up this build and deploy into a testing environment, and they will deploy into testing environment where my testing job will be executed. So we have a testing job, and my testing JUnit job will be executed, and my testing would start. And based on my testing failing and passing, it would generate an automated report. Let's say it generates an 80% of test cases are passed, right? Then it is a good candidate to deploy in a UAT environment, right? Let's say it is not passing above 80%, so it is not a good candidate for my UAT, right? So what we do, it generates a report and send it back to the DevOps development team, where development team will look at the things. Okay, so many bugs has been reported, right? So they need to further work on that. They will fix the issues, and again it will, when they do a check-in into the repository, the version control tool will trigger a build, and again the build will come and it will be deployed into a testing environment, and again the test cases will be executed. And now if my test cases are passing more than 80%, so that means it's a good candidate for my deployment. So what will happen is the another job will pick up this build and deploy into a UAT environment. So what is UAT environment? UAT basically a user acceptance test, right? So and user acceptance test. So what we do, we onboard business users, right? So customers, few people from customer side we onboard, not the entire people from the customer, but few people who would basically have the replicated environment and who would do the testing, right? So who would do the testing and who would certify that okay, now this product is up to the shape and it is not breaking our existing or legacy environment and it is very much integrated with our environment and we can push it to production environment, right? So all that we can automate it, right? So all that we can automate it. So that is what I was talking about, managing the life cycle of containers with orchestration, right? With the support of DevOps team, and they integrate further with CI/CD workflows. Now, one thing to be noted here is under containerized, right? When we say containerized applications, so microservices are the foundation, right? So microservice architecture is the foundation, right? All application when you host into container based, right? So what we do, we follow microservice architecture and we bring into that thing and we host this application into cluster based environment where we, right? So that is basically a foundation for a cloud native applications, right? So that is basically a foundation for cloud native application, and very extensively we would be covering that thing in our training, right? From the microservice based architecture, right? We will be training you out how to deal with the microservice based architecture, how we will create the services, and since Kubernetes it's an API, so we will be creating all that services and the services do a wonderful job, right? Services will automatically take care of right from my application creation. It will build my container image, it will deploy the container image into a container, I can spin up the container, and it will take care of my container health, right? It will take care of my container resources, whatever is required for that application to run. So all that we will see under that, right? And various other things, and this course is basically intended for all type of people. It is not focused for developers or a testing people or a system engineer or senior system engineer, network support people, everybody, right? So this is the hot thing, and Kubernetes already entered into a mainstream, right? So we will see all that thing. So let's move forward and understand Kubernetes in little more matured way. So what is the importance of Kubernetes in container orchestration? Right, so let's understand Kubernetes. So we have various layer structure, right? So read this slide from the bottom, right? So what we need, so initially we need a machine as an infrastructure, which could be my physical machine or could be my VM machine or could be my cloud-based instances, right? So we need a machine, and on top of that, what we host an operating system, right? So we host operating system on the machine, right? Let me take the spotlight. So we need a machine, which could be physical machine or a VM machine or a cloud-based machine. Then what we do, we host the operating system, right? So we load the operating system. Then what we do, we need to have a container runtime. So container runtime means we need to install Docker. So Docker is very much required for Kubernetes because Kubernetes is dependent on Docker. Why? Because Kubernetes on its own cannot create containers, so it needs Docker, right? So Docker will help Kubernetes to create the containers. Right? Once the container is created, it will do a orchestration. What do you mean by orchestration? Orchestration is something like to manage it, right? To manage it. And this looks very simple thing. Okay, just we need to manage it, but it's a very huge thing, right? So all my complete deployment will be handled by my orchestration layer, right? So what is orchestration layer? So we have a resource management where we have CPU, memory utilization, and everything. So which will be my resources will be managed by my orchestration, right? So dynamic resource allocation will be happening here because when my application is up and running, I cannot upgrade or degrade my resources. So whatever I have to provide my application, as and when the traffic increases, my resources should dynamically also be allocated to the application so that my application should always run in a healthy state. So this resource management is basically a layer under orchestration. Then we also have a scheduling, right? Scheduling is basically helps where we plan our deployment, right? Where we plan our deployment, right? So I can plan my deployment, right? My future deployment, right? Tomorrow, if I want to do some deployment, I can take a status of my cluster and we can even deploy, we can schedule it. Right? So we have an inbuilt scheduler, right? It's an inbuilt. We need not to bring anything from outside. When you install Kubernetes, all these things will be embedded into the Kubernetes, and internally Kubernetes uses all that thing, right? So we have a scheduling here, which will help me to schedule my application for deployment, and we do all that thing. We also have a service management. As I said, we host application into microservice based architecture, right? So we deal with services, right? So we manage the complete application into a service management layer. So each service will figure out what what other services are doing inside the cluster, and they will manage the entire thing, right? Entire deployment will be managed by these things. So we have a service management, and we will be playing with these services. We will be eventually creating the services. We will be playing with the services, both internal services, external services, all that we will be seeing in a minute. And that time I will talk more about these services. And finally, what we do on top of that, we have our application, right? So it's the modern world where we host application, web-based application, and people can access my web-based application across the globe. Anywhere in the corner people are there, they will just go to the browser, put the URL, and they will be able to access the application, right? So, and we have a API-based application, right? So we have a lot of microservice-based things. So through services basically eventually provide the access to the outside world, right? When the applications are hosted inside the cluster, and it provides the access to the outside world, right? So other people, right, who wants to access my application, they will access through the services API and web application, right? So people can access it, right? So it's a very simple thing, but internally a lot of things. So we will understand all the structure, right? What are the things under my container runtime and orchestration thing, right? So we will understand this thing in a minute, and we will move ahead, and we will pick up all the things, and we will understand in detail. So let's move forward from here. Now, what is Kubernetes, right? So let's understand Kubernetes, right? So Kubernetes is basically an open source tool which is developed by Google, right? So Google, what happens is, when Google was pioneering into a container based application, so Google was hosting all the application into container based environment, right? Today if I say www.google.com, right, eventually Google is running millions of pod every day, right? So when I say www.google.com, it will go to Google application which are hosted inside the containers, right? And there are millions of containers which are already there in Kubernetes, because in Kubernetes we can have up to 5,000 machines can be created in a single cluster, right? So that's a huge infrastructure, right? And on single machine, on a single node, I can host up till 100 pods, right? So up till 100 pods can be hosted. So if I multiply 100 into 5,000 machines in a single cluster, it would be in million, right? So millions of containers can be hosted inside a single cluster. So that is the power of Kubernetes, right? So I'll give you some use cases also, right? So Netflix, right? So Netflix is the use case, one of the use case where Kubernetes got overnight hit, right? So nobody was aware of Kubernetes before Netflix and other use cases which happened, right? So I'll give you one use case of Netflix. So what happens is, when Netflix they come up with a Netflix application, so what they thought is, they were pretty much happy if they were able to cover up all the states across the US, right? So they thought that if we cover up all the states across US, and if they have a huge customer base across the US states, they are good enough, right? So their company will come into the profitability, they will get the ROI, return on investment, and they would be happy and happy guys, right? So all that were happening into the Kubernetes. But what happens into Netflix, right? So what happens is, they hosted this Netflix, and eventually what happens is, because of the backbone, right? Backbone is nothing but an infrastructure which requires for this application to run this application into a much more healthier state. So what happens is, the customer base was increasing huge, and eventually the Netflix was not happening, right? So Netflix was stuck in between, and the way, because it's an ongoing streaming application, you need not to download anything, right? So what happened is, they were literally struggling because the application itself was stuck, right? Their servers were stuck, and they were not able to find out how to scale up, right? So they were run into a lot of issues. So what they happened is, they already heard about Kubernetes. So they approached the Kubernetes, and they said that, okay, can you help us, because we have our huge application, and our application is we are not able to scale up because of the huge traffic, and it's an online platform application. So what happens is they deploy the Netflix into Kubernetes cluster, right? And rest is the history, right? So rest is the history, right? So now Kubernetes, wherever you are, you put your application into Kubernetes cluster, and wherever you are, right? So today, if I want to access Netflix, so Netflix has reached, right? So they have reached to the global environment. They have reached to the global deployment using Kubernetes, right? So now Netflix is not only the thing of US states, right? It's not only limited to the US, right? It is already reached the across the continents, right? It is already reached across the continents. So same way, everybody is looking for a global deployment, whether it's a shopping application, or it's a banking application, or it's an online training application, or it's a business application. Everybody is looking for a continent reach, right? So they can reach across the continent, and people should be able to do that. And today, if I look at Netflix thing, I can play Netflix wherever I am. I need not to sit at a particular place, or I need to go a multiplex thing, and then I can watch the movies or a webinar, or ongoing web series, right? Or music things, right? Wherever I am, right? I can play it on my laptop. I can play it on my PDAs. I can play it on my mobile while I'm traveling or driving a car, right? I'm on flight or I'm traveling in a train, right? Wherever we are, we can do all that thing because the backbone is Kubernetes, right? The similar example is about another example, right? So Pokemon. So like Pokemon is another use case of Kubernetes. So Pokemon, when we launched the game, so they had an expectation, right? So they thought that if they get a customer base of 50,000 users, they are good enough, right? So their main purpose is solved, and the company will be again in a happy mode, and everybody would be happy, and they will make a profit out of that. So they thought that 50,000 users base, if they reach out, then they are good enough. But what happened, the Pokemon, when it was released, and because of the word of mouth publicity, right, within a week, right, everybody was started downloading and using Pokemon. But the thing is, the application was not running, right? So application was, they were not able to download, they were not able to play that gaming application Pokemon, right? So what happens is, eventually it was spoiling their name, right? It was spoiling their name, and they were not able to, they were literally struggling it. And they already heard the story of Netflix, so they again approach Kubernetes, and they deploy their entire gaming application into Kubernetes cluster based platform. Then after that, right, Pokemon was again a hit. It's a super hit, right? Within a week, it was so popular that everybody was downloading and playing Pokemon, right? So that is the power of Kubernetes. So we will understand all that, right? So what makes Kubernetes so great, right? So here are the some core features which already I have outlined for you. So we will understand all that core features here, and we will see. So self-healing, right? Self-healing is Kubernetes offer this thing. So as and when, let's say in middle of night, right, some application has stopped working, and middle of night it is not coming, right? It is not coming up. So what happens is, until next day when I go to the office, and when I look at into my data center, and when I see that okay, something happened in middle of night, some applications are already stopped, right? So eventually I have to go, I have to look into the thing, I have to troubleshoot, and I have to bring back this application back into the cluster, right? But in Kubernetes, that is not the case. Kubernetes will not wait for until unless somebody will come, right? Kubernetes is basically a self-managed cluster application, right? So it will automatically heal the application immediately, right? That way Kubernetes maintains the state of the cluster at all the time at the same level. So that is the power of Kubernetes. So it has its own self-healing thing. It will not wait for me or you until next day to go to the thing and then look at the application and bring that application back into the up and running mode, right? So Kubernetes will automatically do a self-healing, right? So it is one of the core feature of Kubernetes where they will do a self-healing. We also have automated rollbacks, right? So what happens is, my development is constantly happening, right? So development is an ongoing thing. We cannot stop development, right? So every quarter or every 6 months, right? So development team is releasing a product release, right? So they are coming with a new more features and all the bug fixes in my previous version, and they are coming with a new product release, right? But in my cluster, all my applications are running on the previous version, right? And now I want to upgrade it because development team already released a product version, right? They have already come up with a product release. So I also want to upgrade my application. similar whatever my development team has given to me, I want to upgrade it. So what we do, we upgrade the application without bringing my production environment down. So absolutely with zero downtime, we can upgrade the application, right? So on the fly, on the go, that is the power of Kubernetes. And once I upgrade it into a higher version, and later I feel that this new upgrade is breaking the functionality of my application and it is not up to the mark, right? Though it is tested and everything is done, right? It is certified by a testing team, but still we never know, right? So all that bugs and all that production bugs, right? So all that time we are reporting now and we are not happy with the thing. So what we can do, we can even roll back to the previous version without bringing my production environment down, right? Absolutely with zero downtime, I can automatically roll back to my previous state of the cluster, right? So that is again a core feature of Kubernetes, right? Auto scaling is another feature what we do here under auto scaling. So under auto scaling, right, as and when my traffic is more, right, during peak hours, it is expected that many people will connect to the application. They do shopping, they will do banking transaction, right? A lot of things will happen during peak hours, right? So during that time, what will happen is Kubernetes has an inbuilt feature. So what they will do, it will do a scaling, right? So automatically my application will scale up, right? Automatically it will scale up. And if I need my application which is hosted on particular nodes, and I need further nodes also, because all the nodes are running on their maximum capacity, right? They have already reached to a threshold value, right? So what will happen is it will add a node and it will deploy the application automatically, right? So during peak hours it will do auto scaling up, and when the during off hours, right, during the night or during the off hours when the traffic is less, it will do a auto scaling down, right? So that way it will release the resource, and that way I can optimize the cost also, right? Ultimately it's a pay as you go model, so I can use auto scaling, right? So we have, right, so we have lot of things, right? So we have HPA, which is horizontal pod autoscaler. We have vertical pod autoscaler for all that we do, and that is an inbuilt capability of Kubernetes. Load balancing, yes, when you deploy any application in production environment, load balancing is the thing, right, which automatically manage your traffic and it will do the load balancing. So what happens is internally when your application are hosted into a pod, right, and when you forward your traffic, so when the traffic is forwarded to the pod, I will always ensure that my application which is running inside the pod should always run in a healthier state, right? So load balancing, what it will do, so they will, to maintain the health of my pod, to maintain the health of the applications, so load balancing, it will route the appropriate traffic to the appropriate pod, right? So that way the traffic can be forwarded to the various other pod, and because of the auto scaling it will further scale up and the traffic can be further forwarded to the thing, and that way all the applications which are running on my pod will be on under a healthy state. So that way we have a load balancing, right? So we have lot of load balancing here. We have ingress, we have nginx, like lot of load balancing here, right? AWS, they offer their own load balancing. Azure, Microsoft, they offer their own load balancing. So all that we will see. Under Kubernetes, for load balancing we use services, right? So we have a load balancing service and we will do extensively hands on with that service. We will be playing with that services when, right, during the training, right, during the course training of the thing, we will be eventually will be creating the load balancing thing and we'll be playing with all that thing, right? So that is all about Kubernetes. So let's move forward and understand other part of the Kubernetes. So Kubernetes is, as I said, is already entered into a mainstream, right? When I say mainstream means it's a de facto deployment application, right? So now every big player, right? Whether it's a AWS or it's an Azure or it's a Google Cloud, right? Everybody is offering Kubernetes as a SaaS model, right? As a software as a service model, they are offering it, right? So Kubernetes, nobody can escape with Kubernetes, right? So they cannot escape without Kubernetes. Kubernetes is already entered into the mainstream. When I say mainstream means all the big players, whether it's an AWS or Amazon, they are also supporting Kubernetes, right? So they have COPS cluster and now they have renamed it, right? Previously they used to have COPS cluster, which is a ready-made Kubernetes cluster. Now they have EKS, which is Elastic Kubernetes Services. Same way Microsoft also supporting Kubernetes with AKS, Azure Kubernetes Services. Same way Google, it's a Google's baby because Google has developed this Kubernetes. So they also have, right, GKE, which is Kubernetes thing as a SaaS model, right? is nothing but Google Kubernetes engine, right? So they have, so because Kubernetes already entered into mainstream and everybody is supporting Kubernetes, right? So these are the advantages which makes Kubernetes so big, right? So Kubernetes is an orchestration application, and because of its core features, right, Kubernetes is leading into in comparison to other orchestration tool. Kubernetes is the leading into the market, and it is making huge buzz in the market, right, because of the self healing, right? So self healing, so it will auto repair thing, right? So it will not wait for you, me, or everybody. It's a self managed thing. It will manage my application into a healthy state. So self healing capability they have, inbuilt capability. Let me use spotlight here. Then we have a rollout and rollback, right? So rollout and rollback, as I said, without bringing my cluster or production environment for absolutely for even a 0 second, right? So absolutely for 0 second, no shutdown time, right? So with absolutely without shutdown, right? We have rolling updates, and we can even do rollbacks also, right? We will see all that thing. It's again an hands-on thing. We will do a lot of projects, right? Live example, real-time example, and we will be understanding all that thing in much more deeper sense. Automated scheduling of container based on resources, right? So I can automate my deployment plan, feature deployment if I want to plan. Nowadays, if you see all banking application, right, everybody they plan their maintenance and their their upgrades and all that thing, right? So when nobody is there, right, during the middle of night, right, so normally, right, during the very off hour, right, so normally between 2 a.m. to 4 a.m. in middle of the night they plan all that thing, right? So I can even plan all that automated scheduling also, right? So a lot of things can be planned, not only from maintenance perspective, but during my peak hours also I can schedule it, and automatically it would be taken care, right? So even I have a long weekend, I need not to worry about anything. I can do everything, my plan thing, and my automatic scheduler will help me, and it will host all my application, and it will also dynamically allocate the resources, because there are certain applications they need bare minimum resources, right? Let's say for a database application they need bare minimum CPU utilization, bare minimum memory requirement. Let's say 4 CPUs and 8 GB of RAM is bare minimum requirement for my database application, right? Nginx is the world fastest web application, right? So for that also we want to reserve some resource. So both ways we can do all that thing, right? I can reserve the resources, or dynamically also it can be allocated. So all that we will see as a capability of Kubernetes. So this is again an value added feature of Kubernetes. It's a core feature of Kubernetes. Then load balancing, right? So load balancing, as I said, right? So when we have a production environment without load balancing, my applications cannot run in a healthier state. So we will see all that thing by, right? So we have couple of load balancing here, Nginx and Ingress. So Ingress controller, and we do a lot of things. We also create services. So load balance is again a core feature of Kubernetes. Resource tracking and logging, right? So it is not only just allocate the resource, but it also track the resource. It is all my Kubernetes applications which are hosted into Kubernetes cluster. All my applications are constantly monitored. They are being monitored by my Kubernetes controller. So there are various controllers who will constantly monitor my application, and complete tracking will be done there, right? And they generate a lot of logging, right? So we have a inbuilt logging capability for Kubernetes. We can even integrate, right? We can even integrate, right? So all that can be done here, and complete tracking is happening inside my whenever the applications are hosted inside Kubernetes cluster. So we will see all that. Role based access, right? So we also want, because we want to give specific role to the specific people, right? So development team, they need a specific kind of role, right? So when we deploy to testing, they need a specific kind of role, right? Let's say read only thing, right? They cannot create the thing on the fly. They want to test it, my application, the sanity of my functionality of my application, sanity of my application. So all that thing, so they need some profiling, and using those role based access they will be testing my application. Some people, when end users they want to access my application, we provide some kind of privileges. For admin to perform admin activities, they need a different time of role based access, right? So all that can be managed by, right, rollback access across the Kubernetes cluster. And another thing is, same cluster can be accessed by multiple teams, whether it's my development team or a testing team or my support team, right? Same under the same cluster, under the hood of same cluster, multiple teams can work parallelly, right? They can collaborate and they can work parallelly without interfering other team, right? What testing team is doing, nobody knows, neither my development team nor my production team. What my production team is doing, not, right? So nobody knows about it, right? It is not, right? So nobody will interfere, whether my development team or a testing team, whoever other teams are also parallelly working on the same cluster, they will not interfere. So everybody will be working within their own boundaries, right? So that is the power of Kubernetes. Helm charts, right? So Helm charts is basically, it's a de facto, right? It's a de facto standard of Kubernetes packaging. So we can package all the application, all my dependencies, application prerequisites, my main application, my post configuration, everything will be packaged into the thing, so that the same configurations, when another other people want to use it, they can, I can package it and I can ship it and they can use it, right? For customer also, we package the our entire application and we send it to customer thing, right? So Helm charts basically, they are a repository based thing. They have inbuilt capability where it's a de facto standard for managing my Kubernetes packages. So it's basically a packaging manager for Kubernetes, right? So it's a de facto standard and we will do a lot of things. So that is also part of your training, right? So this is what Kubernetes makes great, and these are the only few core features I have selected, right? There are huge hundreds of features are other there, right? But those are the common features when I compare with Docker Swarm, which is again an orchestration tool from Docker. We have also from Mesos tool, which is again an orchestration tool from Apache, but Kubernetes is leading and it is already entered into a mainstream, right? So that's all about Kubernetes. Now let's talk about the job market and opportunities on Kubernetes. So let's talk about the things. So what we have it here, I have some sample links here for you. So we'll go through the links and we will see, right? So what is the payout for the Kubernetes, the people who are coming with Kubernetes skills, what is the salary, right? The market is offering what, that way it will give us, like that way it will give us the more insights into Kubernetes, and we can also add as our skill set, right? We can also evaluate our skill set. So let's explore the market trend and then we will come to know. So this is basically a payscale.com, right? So it's basically a huge research portal where all kind of skill set, what is their market trend, what is their market value, right, in terms of salary and all that thing, which will give you much more clarity here, right? So let's come here and find it out. So salary for skill for Kubernetes skills, right? How much the offering? So what they are saying is 116,000, right? In terms of dollar, right? $116,000, right? So per annum, right? So it's a per year, right? So you can click on hourly based also. You can get the hourly rate. So before getting into hourly rate, what we can say, software engineer is the minimum experienced guy, right? So software engineer, when he is trained on Kubernetes and when he looks for a Kubernetes job in the market, right? So what would be his average salary? So can you look at this figure, guys? Right, 102k, right? 102k USD, right? Similarly, senior software engineer, right? 134k, right? So it's a huge thing, right? So Kubernetes, and that is the reason under MindMajix we train people practically with hands-on experience, and we train people in such a way that tomorrow if they get into the new job, or they upgrade into the same existing company, they want to upgrade their role, right? All that we help, and this is the normally market trend, and that is the reason we have a lot of, right, job openings also, right? And for development operations also, for DevOps engineer, right, 100. So it is, if you look at the thing, average salary is almost, it's crossing 100k, right? It is already 100k plus, right? So that is what it is here. You can also go and you can explore this thing, right? If you want to explore about state wise or country wise, you can do that also, right? So many things are there under DevOps. If you are looking for reliability engineer, software engineer, developer engineer, all that are there, and you can go, right? Many pages are here, right? So you can go and you can query, right? And you can even, wherever you are, just go and get it. So this is for Kubernetes, which explicitly I have filtered this thing for Kubernetes, right? So you can just go and you can get it. So this will just give you a fair idea about the market, how the market trend, and what is the demand of Kubernetes, what are the salary offerings, right? So this is another portal which talks about market strategy, right? Which talks about market trends and Kubernetes salary, Kubernetes skills, Kubernetes values, what are the penetration in the market in terms of Kubernetes jobs, right? So they are talking about the state-wise also, right? So it's a very recent report, right? May 30th, right? So you can also go here and you can say why it is showing me like this. So since, okay, so they have a last year, right? 1 year plus report is there, right? So almost a year, and they have all the things, right? So since last 1 year data they have uploaded here, and you can go and you can get it all the details here, right? So you can also get some preparation for your interview question also, right? How to prepare. So they will guide you here, right? So they also talk about this is like on a higher side, right? National average salary for Kubernetes job, right? Since last 1 year, right? I'm talking not about far, right? I'm talking about last year. And Zap Recruiter, they have done their research and they have published it here, right? So almost all the people, all the market players, they have done the research and all the reports are published. This is from Zap Recruiter. Here you have Capital One, right? So all that you have, right? So here you have from the pay scale, which we just now we saw, right? So likewise, we have various numerous things, right? So LinkedIn also, right? So LinkedIn also is right. So 100, right? 1,000 plus jobs are already there, right? So already they have posted, right? So tons of jobs are also there, and are almost from 10,000 from January onward, right? So every now and then they keep on adding it, right? So that time it was just 15,000, then 9,000, then 50,000, and it has increased. So it is increasing month by month, right? So as I said, it is already into six figures, right? It's already into six figures, 100, right? It's already 100,000 USD, right? So that is the salary bracket, and you can further dip down and you can get it, right? Glassdoor and other people also, right? So complete research is here under this link, right? So this link will give you a lot of things, DevOps engineer thing, senior software engineers, right? So all that thing. Right, so this is where the market is heading to, right? And this is where even the salary offerings are very higher because the huge demand is there, right? And we are still in transition mode, right? So people are still adopting, right? So they are still in adoption mode. So we are not full-fledged into DevOps market. We are not into full-fledged Kubernetes thing. As I said, Kubernetes already entered into mainstream. So that is the reason the job opportunities are more outside the world, right? Job opportunities are more. Right, so guys, please explore these links, right? So you can further go deep down and you can get the idea of it just for you, right? So everything is for you. We have put it here so that you can also feel, right, what is the value of Kubernetes. Now let's explore Kubernetes furthermore and let's understand Kubernetes, right? So what we are going to cover Kubernetes. So this is the simple architecture of Kubernetes where we have a master and we have a worker node. So it's basically a client server thing, right? So we have a server as a master node and we have worker node, right? So master node is basically, as I said, Kubernetes is a self-managed cluster management application, right? So it's a self-managed thing. And who will manage? When I say self-managed, master node is the guy who will manage my cluster. So if you look at it here, we don't host application, right? So no pod is running on master node. Master node job is just to manage it, right? So master node will manage my Kubernetes cluster and all my application will be hosted on my worker node, right? So we have worker node and we have a pod which are running, and inside pod my container are there, and inside my container my applications are hosted and they are up and running, right? So we have master node and we have worker node. So here we have four nodes. One of them is my master node and three are my worker node, right? So this node. So what do you mean by node? So here we don't say my server machine or my desktop client or my VM node or my VM machine. What we say node. Node could be my physical machine. It could be represented. It could be my VM machine, virtualized machine, or it could be my cloud-based instance, right? So all that we don't categorize separately. We just say node, right? So node is basically a physical machine. It could be a physical machine or a VM machine or a cloud-based instance. So node is a machine, right? So master node is on a separate machine and we have another machine. So we have a four machine inside the cluster. So that is how we create our cluster, and for training also, right? So we create cluster as a production environment. So master node, so if you look at the component wise, so master node has some components, right? Some component, let's say etcd, it is also called as etcd. Some people pronounce as etcd or etcd. So etcd is basically where we call as an embedded data store, right? So it's my data store and it's an encrypted data store. All my secret, password, token, everything is stored here. API service is my front end where all my deployment and everything will be planned, and API service is the front end for end users. For you, me, we will be accessing the Kubernetes cluster through API server. Your scheduler, as I said, it's an embedded inbuilt thing. We need not to bring anything from outside. When you install Kubernetes, all that component is automatically there. So they will be get created, right? So they will be internally Kubernetes will create all these components, right? So my scheduler and controller manager, which will help me for healing and managing and scaling up, scaling down. We have controller manager. Worker nodes. Every worker node has to have two components, kubelet and kubeproxy. So kubelet is basically a service who will manage the my worker node, and kubeproxy is basically a firewall thing. So whenever anybody wants to access my application, so kubeproxy will validate the request. If the request is appropriate and authorized and authenticated request, it will allow the access, and if the request is not validated, it will reject the request. So it basically acts as a firewall, and every node, these two components will be present. Kubelet is basically manage the entire node, and kubeproxy will validate the thing, right? So every node will have it, and my pods will be deployed. Master node will deploy this pod, right? So everything will happen through master node. So when we enter into the cluster, being there at a master node, we can see the entire cluster. There is no other way we can enter into the cluster, right? So that is the normal architecture. We will deep dive when we go into the Kubernetes cluster. Right, installation process. So let's talk about installation, because there are numerous ways we can install Kubernetes, and you must have heard, right, various things, right? So when we talk about Kubernetes, so installation is another hot topic when we talk about Kubernetes. So there are numerous ways of installation. So kubeadm, so what we do, we install Kubernetes on a bare metal machine. Nothing is there, right? From foundation, from ground zero, we bring one by one, right? We bring one by one, right? So we create the cluster, Kubernetes cluster. So it's a bare metal thing. So we create Kubernetes cluster on bare metal thing, right? We also have Minikube. Let's say when we don't have much thing, right? When we don't have many things, right? So at home we don't have multiple machines and all that, but still we want to install Kubernetes. So what we do, we install Kubernetes called as a Minikube installation. And here what we do, we create a virtualized Kubernetes cluster environment, right? So we will talk about this Minikube, which is very powerful, right? We can quickly set it up on our laptop also, right? By having a virtualized tool, and we can set it up, right? So we can even do that. But for us, for at MindMajix, we always do with bare metal installation. Nothing is there, because we need to also understand how the cluster is created, how the master node is created, how the worker nodes are created. So we should know all the challenges when we set up the cluster. So we always go with the bare metal, which is our preferred installation, right? Kops cluster, it is a ready-made cluster provided by Amazon, right? AWS, right? So previously, initially they were saying Kops cluster, but now they have renamed it by EKS, Elastic Kubernetes Services, right? SaaS model. So it's a ready-made cluster, and what we have to do, we have to just spin up the service, start the service, and start consuming, right? So we can directly consume the Kubernetes cluster from AWS, and they will charge based on the utilization, right? Hourly basis, right? But for our learning purpose, this is not the ideal thing, right? Ready-made cluster, if we use, then we will never ever come to know what are the challenges, how to set up the cluster, right? Same way we also have from Google, like GKE, so Google Cloud Platform. Here also we have Kubernetes as a SaaS model. We also have Azure, right? AKS, Azure Kubernetes Services, right? All these are ready-made cluster, right? They have a 3-node cluster, ready-made cluster, right? Whenever you start the service, Kubernetes, they will spin up on 3 nodes, and automatically a cluster will be there, and you can directly go and use it. But for us, as a de facto, we will go with a bare metal thing, right? From ground level, I will take logical machines, right? Cloud based, normally we install on cloud, so we will also train you on cloud. That is the part of your training, right? So, and we will have multiple machine, logically we will group them, and we will create cluster, and we will set up, right? We will set up master node, worker node, one by one, we will do that, right? So now let's understand the bare metal thing. When we talk about bare metal thing, so this is how we create Kubernetes cluster. So it's basically a 6-step process, right? Kubernetes cluster, what we do, as I said, we create separate machines. So here, let's say we have 3-node thing, right? So one of node, I can name it as my master node, worker node 1 and worker node 2, right? So that way we will set it up. And as I said, Kubernetes always dependent on Docker. So we have a Docker dependency, then we install Kubernetes on the thing, then we initialize on one of the thing. The moment I initialize, that particular node will become my master node, right? So I initialize. Then we create Kubernetes doesn't sit on base network. It will always create its own network, right? Because of its security reason, right? Because of the security, it has its own capability where it will deploy its own certificates, and every component has to have its own certificate. Then only they will communicate. Without certificate, they cannot talk. So what we do, Kubernetes creates its own network called as a pod network, and there are various vendors who works with Kubernetes, right? So we will see all that, right? So use in and we create pod network, then we can join this worker node 1 and worker node 2, and that way we can set up entire cluster, right? So this is the thing which I will be taking as a part of the training, and then I will provide you the steps, and you will also have to set up your own cluster, right? You also have to do, because it's a purely hands-on thing, right? For quickly set up the development environment, right? So we can set up development environment by using Minikube, right? So as I said, on, let's say if you have at home and if you have only one computer, your desktop or a home computer or your personal laptop, what you can do, you can even set up your virtualized environment for Kubernetes, right? So normally we can set up a quick environment for Kubernetes, right? So what we do, we create a virtualized box, right? So we just need to, because your laptop must be having Windows OS, so what we need, you just need to create a virtualized box, right? Oracle virtualized box on your laptop. I will guide you the steps. There are steps and we will do all that. So you can quickly do that. Then you can set up the nodes, right? You can run, you can create a virtualized environment. Once you have the virtual box installed, you can set up the virtual environment, and you can create a single node, one node cluster, right? Minikube is normally having one node cluster you can create, and you can use for your development activities or for your testing, right? So you can use for that, right? So it's a basically a trimmed version of production environment. It's a development environment. It is not a production. Production environment is a huge thing, right? When I say trimmed version, means here the load balancing thing and, right, scaling thing will not be there, right? So with the bare memory thing, otherwise you can play with Kubernetes, right? So you can play with Kubernetes, you can create your pod, you can host the application on the Kubernetes container, host the things, create your pod, deploy the pod, right? All that you can do, right? So it's a single node application, all that you can do, right? So we will also do as a part of your training Minikube, and then eventually we'll move towards a production environment where I will be talking about the complete master node, worker node, and various other thing in my cluster. So both the installation we will do during as a part of the training, right? Types of services, right? So type of services, so a lot of services are there, and if you see inside my background, we already have a cluster environment. So this is my cluster environment, and my pods are already running, right? On my cluster, various nodes are there and internal pods are there. So these services, right? What is the importance of these services? So Kubernetes services, basically the services will provide the access to the outside world, right? When we deploy the application inside the Kubernetes cluster, those are the internal things. But when I want to provide the access of my application to the outside world, I will always use these services. So basically there are 4 types of services which we use as a core service of Kubernetes, right? So we have a cluster IP service, basically an internal service, right? So Kubernetes cluster IP service which will maintain the communication across the cluster, right? So it has its own IP, and as the name denotes, cluster. So this service is running across the cluster-wide service. It is running on its own IP, and it's basically an internal service where all the pods can communicate with each other, right? It could be my database pod or my web-based pod or my, right, middle tier application or front tier application, right? All that we can have. Node port, when we provide access to the outside world, right? So node port service will it will enable the access to the outside world, right? So my applications are hosted inside the cluster, and the cluster access can be given to the outside world by a node port thing, right? So what we have, as the name indicates, node port. So there are 2 things: the node IP address and the port of the node, right? So the node IP address and the port of the node, right? So right, we have 30,000 to 32,767 during that range, right? So we expose the thing, and we can create our own endpoint, and using node port people can access my application which are running inside the cluster. Load balancing, yes, in production environment we have to have a load balancer which is offered by a service provider. If I'm using Amazon, right, Amazon will provide load balancer. If I'm using Azure, Microsoft will provide, right? So all that load balancer we can have. And in my production environment, even load balancing is a type of service object, and I can create endpoint, and this endpoint, through this endpoint people can access my cluster, and at the same time I can do load balancing. So all that we will be doing extensively, complete hands-on session. One by one we will be creating these services, and we will be deep dive with these services, complete hands-on experience with these services, and then we will see how we can provide access of my application to the outside world. So I will be doing the testing, right? Once I deploy, wherever you are. Let's say in my batch, people are connected from India, from UK, from Asia Pacific, Middle East, and from US, right? Everybody can access that application once I deploy in my Kubernetes cluster. So it's going to be very, very interesting. External name service. So it's external name service basically when you have a domain, registered domain. Let's say Google, they have registered domain, MindMajix have their own domain. So with the help of domain, I need not to, I can create my endpoint by my some external name, right? So www.google.com or www.mindmagic.com or www.example.com. We can even give name to my cluster and people can access it, right? So when they on the search engine or on browser they say www.mindmagic.com, they will open my application, they will do. If they want to go to banking application which is deployed in my cluster, right, I will provide them with the through external service, they can access it, right? So www and banking name they will give, right, chasemanhattan.com, and they will open the thing. hsbc.com, they will open the thing, right? So all that can be provided. So it's again a production use case, and we will understand the thing in a production environment, right? So it's again a part of your training, right? So we'll have a complete hands-on on services, right? So another thing which we cover, probably this is the last slide, I will not take much of your time, this is the last slide, right? So what we do it here, right? So here we have secrets, right? Because without telling about the secrets, my story is not complete in Kubernetes. So what we do, so secrets is basically a Kubernetes secure object, right? It's a security object. It's a secure object where all my authentication, my auth token or my SSH keys or my secret password, right? So my key value, all that thing we will store under the secrets, right? So all that thing we store under secrets. And what we have a blue-green deployment, right? Blue-green deployment is also another going to be very, very interesting, right? So we also call it as a canary deployment or a blue-green deployment. If you see it, it's basically we have a two production environment called as application v1 and application v2. Initially we come with a blue, right? It's an environment called blue and another environment called as a green. So by color also we can denote it. And what we do it here, right? So v1, in v1 what we have, let's say my initially when we create the cluster, we deploy the application at the v1, and my development is also parallelly going on, and after 3 months or 6 months they also come with a product release. So what I do, I deploy it here in my another environment, because I have two production environment, right? Previously we used to have a master slave architecture, but here we use no slave architecture, we use master master, right? So what we do, one of the environment I deploy the higher version of application which my development product release is already done, so which is on higher version. So this is running on still on older version, and all the traffic is now, right, managed by v1, and this guy will quickly go down, right? It has all the complete details of this environment, quickly go down, it will upgrade the application which my development team has come has already released, they have already done the product release. So I deploy the new product upgrade here, and I can upgrade this quickly, do a sanity check, and I will just do a sanity check, making sure that the new deployment is not breaking the functionality, and quickly this will bring and join the cluster, right? And all the traffic will be routed to this guy, right? So seamlessly the traffic would be forwarded to this guy, and eventually this guy will go down, right? And it will also upgrade to v2, right? So now both are running v2, right? So both are upgraded. Now after a few months, again after a few weeks or few months, again my development is coming with a new product release, let's say v3, right? So one of machine will again go down, it will upgrade, and the whole traffic will be handled by these guys. So at an at any point, right, I will not at any point my production environment will never ever go down, right? It will, with the help of blue green deployment strategy, what I can do, I can upgrade my application, right? So again we will have some use cases here, and we will also deep dive with blue green deployment, right? So that is also going to be your one of your module in your training program, right? So I'm done from my side, right? So that's all from my side. If you have anything from you, so it's open for question and answer session, so it's open for everyone. Now you can unmute yourself and you can ask me any question relevant to Kubernetes. If you want to seek any clarification or any information or anything which I have not discussed so far, and if you want to bring it on the table, you can probably take it up, right? So over to you guys. Right, any question if you have, guys, anything in your mind, right? Installation we
Yeah,
do on, yeah. So just 1 second, I missed one point. Installation we do on cloud. So if you know the cloud, we do on AWS, right? I'll create your free tier account and we do on AWS thing. So cloud thing, if you know the cloud thing is well and good. If you don't know the cloud thing, that is the part of the course. I will be training you on cloud side also, right? Because no point in just installing Kubernetes on physical machine or VM machine. People, the whole world is talking about cloud. So we will do complete installation by using modern way of deploying Kubernetes, that is cloud. So we will be installing Kubernetes on cloud thing, right? I would be installing on AWS thing, and it's a production environment, and I will give you the steps, and you also need to do the installation, and I will help you. I will train you on AWS side, so don't worry about it, right? So that is the expectation from me, and I'll bring you to that speed. Another thing is Kubernetes. Normally it goes very well when we talk about production environment. It goes very well on Linux or Ubuntu environment, right? So we also do Kubernetes installation on Linux and Ubuntu. If you are well and if you are aware of Linux environment, well and good. If you are not aware, don't worry about it. That is also the expectation from me. I will be training you on Linux side also, right? So Linux is also part of your training on Kubernetes. Linux, you will be trained on Linux also, and side by side Ubuntu. Ubuntu is another flavor in Linux. It's the new thing. It's a modern way of Linux operating system, Ubuntu, and it's a lot of capability they have added, right? A lot of new features they have already added, a lot of capability they have added, and we will explore Ubuntu also. So I would be creating entire cluster on CentOS and Ubuntu, both the things, right? So that way, even Red Hat also we will do, right? So Windows is not the official choice, so Linux is the choice. So I will be training you on that automation side, right? So YAML thing, right? So no pre-programming skills are required, right? So no prerequisites are zero, right? We don't need any prerequisites that you need this and this and this. Nothing is required, right? Right from the ground level, right from the base level, I will be training you on each and everything, right? So from YAML thing also on the fly, on the go, I would be teaching you, and I will bring you to that speed. Not only to just go and read the YAML thing, but to create your own YAML files, right? To create your own manifest file, to create your own definition file where you can create your services, you can create your deployment, everything, right? So I'll bring you to that speed, right? And eventually Kubernetes thing, right? So it's an online thing which we prefer because people across the globe they want to get connect and they want to join for this training. So we prefer online module. And what we do, we normally every day we have one session, right? That would be around 70 to 75 minute session. We say 1 hour, but it always goes because when we have people they ask question and all that thing, right? So we unnecessarily we don't hurry up that okay 1 hour and we want to finish, so we don't do hurry up thing, right? So we always take the pace of the people, how the people are understanding, based on that. So it always goes to around 70 to 75 minutes every day, right? So that is Monday to Friday. Weekends we can take your consensus. If everybody agrees to it, if I'm available, you are available, we can even plan for weekend also, right? So weekend is also absolutely fine based on everybody's agreement. We can even plan for weekend, right? So that is another thing. And certification side, each, as I said, the complete course is crafted by taking the certified modules, right? So our entire course we have certified module, right? Pod, replica set, deployment, config map, jobs, right? Both ad hocs and cron jobs, services, internal, external, right? Namespaces, logging, monitoring, alerting, resource allocation, everything we cover up, taking care of certification thing, right? So we even all our course are there, and fundamentally because eventually before certification you have to understand the tool, right? You have to have a hands-on experience because certification is not an objective type, it's basically a hands-on thing. So I take one special session for certification at the end where I will be training you and I'll be telling you that for certification point of view what are the things you should keep in mind, how you can prepare. I will also give few links for mock test and I'll guide you for certification, right? So all the resources will be provided so that we can prepare you for certification. Certification is a separate thing, right? But we will prepare for you, and certification is basically 300 USD, right? And in one retake, so you get two chances. So one retake is free. If you clear in first chance, well and good. If you don't clear it in first chance, one retake is free, right? So one retake is free, and that way we will also guide you. So I'll take one session, I'll give you a lot of information certification side also. Sorry guys, right? So I take another 5 minutes. Yeah, over to you.
Yeah, thanks for the session. So,
Yeah.
do you have any idea on WebSphere application server, IBM?
IBM WebSphere. So we take as a
Yeah,
container application. So WebSphere,
yeah, this is
WebLogic, all are used. Yeah. So all that we do,
Just
Apache. Yeah.
just want to know what is the difference between the WebSphere and the Kubernetes.
WebSphere is basically your web-based application you can deploy. If you have your application which has your var file or er file, right? Right, var file, er or jar file, you need a WebLogic server, right? So you
Mhm.
deploy. Whereas Kubernetes is a cluster-based environment. Whenever you want to deploy your multi-tier application, where it is front-end application or your back-end application or your middle-tier application, you deploy, right? When you deploy application, you not only deploy application by taking care of scalability, right? Scalability is the thing. Whenever we deploy, nobody will say, okay, I deploy the application, there is no scalability. When in WebSphere, you cannot scale up automatically. It will just deploy and you can run your application. But here you can you can scale up your application, right? You have your load balancing. You can do scale up, you can do scale up and scale down. So auto scaling feature is there. You have self-healing feature, which nobody in the world, no other tool will offer you. Kubernetes can only offer self-healing, right? If your application goes middle of night, your application goes down, Kubernetes will bring it back. It will not wait for until next day when I go to the office and look at the application thing. It will not wait for that, right? So no human intervention is required, and my applications are continuously monitored, right? So monitoring features, scaling, self-healing, all these features are not there. And here I can plan my complete deployment, right? If I want to deploy my application such way that my customer, my user base or my customer base is increasing day by day, right? So day by day, on the fly, on the go, only through Kubernetes I can scale up, right? So I can scale up, my application can be scale up, so that internally inside my Kubernetes cluster, my application would always run in a healthier state. So there's a vast difference between the two.
Okay.
And
So
another thing is, yeah, go ahead.
yeah, go
Go
ahead.
ahead,
Go
go ahead.
ahead. Go ahead.
Another thing is, for WebLogic, you have to have your Java-based application, right? So only particular type of application you need particular type of environment. But here in Kubernetes, I can host any type of application. It is independent, and that is the reason I said it is already entered into a mainstream, right? And the multi-tier application, right? I can host my application into a container-based thing. But in WebLogic or WebSphere, I cannot create container-based thing in a WebLogic thing, right? But here my complete thing, I can build my application, even legacy application I can migrate into a container based application, right? So it's altogether a different platform. It's a containerized platform. I can expose application to microservice based architecture using services. But here in WebLogic, I cannot create services, right? So difference is huge.
Yeah. Thank you.
Did I answer your question?
Yeah. Correct. Thank you. Thank you, Prashant.
Sure. Next questions, guys.
Uh, Hi, Prashant. Thank you for the topics. And I have one question. What is how that Red Hat OpenShift link up with this Kubernetes? Okay.
Okay, OpenShift, what they have done is, right, in the background, we have infrastructure. When I say master node, worker node, and physical, logically, we group the machines, whether it's a physical machine or a VM machine or cloud-based instances. Right, so what OpenShift is doing, OpenShift is automating your infrastructure layer also. Right, they have automated scripts and they have automated thing and they have automated the entire thing, which is basically an advanced thing, right? So they have taken care of your environment also by OpenShift, and eventually they have a Kubernetes layer on top of that, right? But fundamentally, you have to have a Kubernetes in place, then only you can go for OpenShift. OpenShift is basically a Red Hat thing where they automate even the infrastructure layer. The infrastructure management thing can be managed by OpenShift, right? Because a lot of things are dependent on infrastructure, right? So tomorrow my OS is not supported, it is upgraded. Microsoft is saying that they have stopped the supporting OS, so I need to upgrade, right? Patching, upgrade, all that thing, right? Monitoring, all that thing. So OpenShift, they have completely, they have automated the infrastructure on top of Kubernetes layer.
Okay. So it's not like some host, right? Like it's not the some host name kind of thing. Right?
No. It's an environment where you have complete OpenShift, and OpenShift will take care of everything in an automated way. So I would say it's an automated way of managing infrastructure as well as your application deployment, which are hosted in Kubernetes cluster in an automated way by OpenShift. And Red Hat, they are offering solution in automated platform. So OpenShift is one of the solution in Kubernetes.
Okay. Okay. Thank you. Thank you.
Everybody has to offer solution in a unique way, right? Microsoft also their competitor, AWS also there, Google Cloud is also there, OpenShift is also there, and they are big players. But fundamentally, you need to understand the container thing and Kubernetes thing in a much more deeper sense and have hands-on experience. Then you can move towards automation thing. That is the next thing, not the first thing. First place you have to have Kubernetes understanding. All right.
Yeah, what is the link up to the Docker and the Kubernetes? Mainly the Docker used by the developers, I think, right?
No, not like that. Yes, day in day out, they do a lot of things on developer people. They use Docker thing, but for understanding also, right? Docker is basically you expose your application to container platform, right? So your lightweight thing, faster, efficiency, performance, you increase. How you increase all that thing? You have to expose your application into a new platform, into a new modern platform called as a container platform. Once the application comes into the container, then Kubernetes will take over. So Kubernetes on its own cannot create containers, right? It is dependent on Kubernetes. So when I want to create Kubernetes cluster, I have to have Docker in place. I have to install Docker on all the machines as a prerequisite for Kubernetes cluster, right? And once the container is created, Kubernetes, what it will do, it will further take that container, add a new functionality, some other capabilities it will add to the container, and it will be encapsulated into a Kubernetes environment called as a pod, right? So here we don't say container, we say pod, and inside that containers are running, right? So you should know, right, how the applications, when you have a customer source code or when you have a customer application, how you can build the application into a container based platform, right? We need to build the application into a container images, and that I can upload on my registry server, which could be a public or private registry server, and which will people can download and they can spin up the container, right? So that is the thing. But when we talk about a huge deployment thing and maintain the entire life cycle, we need orchestration tool where Kubernetes will come and help me, right? And Kubernetes has an inbuilt capability. It will do a continuous monitoring of my application. It will do a self healing. If anything goes wrong, it will heal my application automatically without needing any people around, right? So it will do that. And plus resource allocation, right? When application increases with the more and more traffic, right? Because it's a production environment, right? So and during that time it will allocate the resources, right? And it will do a load balancing, right? So Kubernetes will have all that capabilities which Docker doesn't have, right? So that is the reason we use orchestration tool.
Okay, thank you.
So how to bring your application to microservice architecture, all that. So both the tools, Docker and Kubernetes, they use microservice based architecture, and that is the reason it's a lightweight solution, and your performance would be very very fast because in the background they use layer architecture, right? So I will be talking about the layer thing, and because of the layer architecture, right, my application efficiency is increasing very very fast, and nobody likes coding in this world. In this modern world, nobody is liking coding. If I say if I go to development and say, here is my requirement, can you build a solution? They will say, okay, we will take 6 weeks or 8 weeks, come back after 2 months. We cannot wait for that long, right? So using Docker, right, with bare minimum of requirement. Another thing is what we do, right? So now the Docker and Kubernetes, they already entered into mainstream. When I say mainstream means earlier the all the IT applications the targeted were for IT people only, right? IT industry and IT customer only. But nowadays every business they have a backbone of IT, and that is the reason with bare minimum configuration, right? My business people, they don't know what is coding, how the application is configured, how the application will run. So what we do in Docker container, we put everything into the container, right, including my configurations also, right? So post configuration, previously what we used to do, we used to provide the CD, we used to provide a document, we used to provide a checklist, we used to provide the installation step. You need to follow this step, then only you will be able to run my application. But now in this modern world, we don't need all that. When I expose my application into a container platform, I take care of configurations also, on which port number it is running, what are the files, what would be my default workspace or default work directory, right? What are my prerequisites, right? Everything it will take care when I spin up the container, right? So we build the container images by taking care of all configurations also, right? Everything will be taken care itself on. We just need to spin up, and that too without installation, right? We just need to start the container. We don't install anything on my physical machine. So everything will be on the fly, on the go, right? I just spin up the container and everything will be taken care, right? So that is the all that thing. It's a modern way of building the solutions, right? Don't worry about
Okay,
it. We will be
this
covering all
console
that
based
thing.
one.
Yeah.
Yeah, there's a Kubernetes has a console based managing.
Yes. So my master node, and we have couple of machines where it will deploy the application. It will start my application automatically, taking care of all sort of configurations.
Okay, so we can do everything from the console as well.
Yes.
Okay, thank you.
Any other questions, guys? If you are not able to reach out me on audio, right, you can post your question on the chat also. I'll pick up from there also. Not a problem for me, right? I got one question. Certification is compulsory for Kubernetes job. It is not the compulsory thing, right? What you need is hands-on experience on Kubernetes, and you should be able to, right? You should be able to perform Kubernetes routine tasks, right? So that way, in this training program, we'll bring you to that speed. So that is the expectation from MindMajix. Will bring you to that speed, right? After the end of the, it's basically 5 weeks course, 5 weeks for Docker and Kubernetes. Kubernetes course, it will take 3 weeks, right? So sometimes based on your speed, you want to take one more week also, it goes to 4 week also, right? So once we train you people, right, in 3 weeks or let's say 4 weeks, that you should be independently able to do that. So till that speed we will bring. Certification is basically a value add, right? When you go to a market, a lot of people they do scrutiny looking at your credentials. So a lot of people when they scrutiny your profile, they also look for certification. So few people, few organizations, what they do, they filter, they do scrutiny based on the certifications, right? So certificate basically it will give you much more value add to your profile, right? So just a value add, and Kubernetes certificate has a lot of value in the market, right? So if you are already into the existing profile, you are already into the container thing, no need for certification. But you want to ramp up your skill, you want to completely, you want to change, you are coming with a legacy and a legacy background experience, and you want to change your profile, I would recommend go for it, right? And one retake is absolutely free, right? So first time you may, right, normally people clear in first attempt after training. When once we train the people, they clear in first attempt. If you get stuck, again you have another chance free of cost, right? So that way first time people, even the experience and they know, and they know the pattern and all that thing. Anyhow, I will be covering, as I said, it would be a separate session. I would be taking and covering that part. Over and above, if you need the thing, right, you can even go for that, right? So just people who want to ramp up with a new skill set, new thing, because a lot of jobs are there only on DevOps and Kubernetes in the market nowadays, right? So a lot of things are happening in DevOps side and Kubernetes side. So it's just a value add, not a compulsory thing. Right, guys? Any other questions? If we are done with the question, then probably we can wrap it up.
Yes, Prashant. Thanks for your session.
Okay, guys. So I think we are done for it. And thank you for your valuable time. Right. Thank you for joining in. Thank you for listening for almost last 80, 90 minutes. So thank you for that. And wish you good luck. Take care of yourself. Stay blessed in this COVID pandemic situation, and utilize your time, right? Take decision, right? Self investment is the biggest, right, is the biggest thing. People should invest and learn the thing. Kubernetes is a huge thing. You need some expertise who can train you and bring you to the speed, right? So that is what MindMajix is, the place where you will be trained, you will be giving hands-on exposure with the real-time experience, production based use cases, production based scenarios, right? And we will prepare you for entire thing with a new skill set, right? You can ramp up and scale up with the new another feather add in your hat, and you can have a Kubernetes skills, and that is where is the whole buzz is about Kubernetes, right? and don't forget the story of Pokemon and Netflix, and everybody is looking for a global deployment, right? So that's all from my side, guys. Thank you so much, and I'll see you soon. All right, then. I'm done for the day. Thank you so much, guys. So I'm taking off from here.
Thank you, Prashant.
All right, guys.
Thank you. Yeah, thank you.
Thank you, guys.